This is guided practice 12, and for 7.3 trig sum, and we're working on number 3. We've got an x squared minus 9 under the square root, so we're going to make the substitution for x equals 3 secant theta, and that means that dx is 3 secant theta tangent theta d theta. And we're going to go ahead and plug that in. So that gives us the integral of square root of 9 secant squared theta minus 9 times the dx, which is times 3 secant theta tangent theta d theta. The 3 comes out front. We factor out the 9 underneath the square root. And we've got secant theta tangent theta d theta. Okay. Not sure why I put that a little higher. Let's move it down. Okay. Let's see. Underneath that square root, we're going to replace the secant squared theta minus 1 with tangent squared theta because of our identity. Then we can take the square root. The square root of 9 is 3. Move it out front with a 3. That gives me 9. Tangent theta, secant theta, tangent theta, d theta. That gives me 9 times the integral of tangent squared theta times secant theta d theta. And now we're going to use our identity to go backwards. So I'm going to replace tangent squared theta with secant squared theta minus 1 times secant theta d theta. And that gives me 9 times the integral of secant cubed theta d theta. And I'm going to split this up. Minus 9 integral of secant theta d theta. Okay. Now, the one on the right, we know. Right? This is minus 9 natural log secant theta plus tangent theta. I showed you how to do that at the beginning of the lecture video. So the question is, what goes here? Okay, and this one's not quick and easy. So let me go to the side and see if we can figure this out. So we're trying to find the integral of secant cubed. And what we're going to do is we're going to use by parts here. So we're going to go with u equals secant theta and dv equals secant squared theta. And the du then is secant theta tangent theta, and v is equal to tangent theta. So this becomes the secant theta tangent theta, that's your u times v, minus the integral of secant theta tangent squared theta d theta. Okay, now we're going to substitute in for the tangent squared. And we get the secant theta tangent theta minus the integral of secant cubed theta, d theta, plus the integral of secant theta d theta. And this, of course, is originally equal to the integral of secant cubed theta d theta. So we get one of these where integration by parts brings you back the integral that you started with. And so this goes as the integral of secant cubed theta d theta is secant theta tangent theta. And then this one down here is plus the natural log of secant theta plus tangent theta, and then minus the integral of secant cubed theta d theta. And when we've been in this situation before, what we do is we add this integral to the other side. And we get 2 of them. So we get 2 integral secant cubed theta d theta. And that is equal to secant theta tangent theta plus the natural log of secant theta plus tangent theta. And then you divide by 2. So the integral of secant cubed d theta equals 1/2 secant theta tangent theta plus 1/2 the natural log of secant theta plus tangent theta. And this, we're going to plug in over here. So we're going to take that back over here, and we're going to multiply it by 9. So I need a little bit of space. We're going to put it in this spot right here. So this is 9 over 2 secant theta tangent theta. Was it plus or minus? It was plus. So plus 9/2 the natural log of secant theta plus tangent theta. And then we're subtracting 9 times the natural log of secant theta plus tangent theta. And this gives us 9/2 secant theta tangent theta minus 9/2 natural log, plus 9/2 natural log secant theta plus tangent theta plus c. Which seems like a lot of work, but we're still not done. Okay. We know that we originally made the substitution here of x equals 3 secant theta. So x equals 3 secant theta. So if I divide those both sides by 3, that tells me that secant theta is x over 3. So that allows me to replace both of my secant thetas, but I also need tangent theta. So in order to get tangent theta, we need to draw a triangle. Secant is hypotenuse over adjacent. So x is the hypotenuse, which is this side, and 3 is the adjacent, which is this one. In order to find this side over here, which I'm going to call b temporarily, we want 3 squared plus b squared equals x squared. Subtract the 9 over. So b squared is x squared minus 9, and b is taking the square root of that. Again, that's the one that shows up in the original, so we're not super surprised by that. So the b is square root of x squared plus minus 9. And that means that our tangent theta, which is opposite over adjacent, the opposite side is square root of x squared minus 9, and the adjacent side is 3. So those two I'm going to use to plug in over here. So we have 9/2 times the secant of theta, which we know is x over 3, times the tangent theta, which we know is 1/3 the square root of x squared minus 9. Plus 9/2 times the natural log of the secant theta is x over 3. And tangent squared is square root of 9 x squared minus 9 over 3 plus a constant. And the last thing that I can do is I actually can cancel these 3's and the 9. And that gives me x over 2 square root of x squared minus 9 plus 9/2 the natural log of x over 3 plus the square root of x squared minus 9 all over 3 plus c. Wow, you can see how quickly these get out of hand, right? They get very involved very quickly, okay?